Okay, so let's start the webinar. Welcome everyone. My name is Sergio. I'm from UNESCO and I'll be your host for today. This time the webinar is dedicated to nature-based solutions for coastal resilience and landslide migration. And our speakers will be providing insights from their work on the ground in the open air labs of the UK, Austria and Italy. Before we dive into the project and hear what our guests have to share, let me just add a few notes. As you might have noticed, your microphones are muted. They will remain so for the entire duration of the webinar, but you can, however, write your questions on the chat box, and they will be put to our guests at the end of the presentations on the Q&A session. If you wish to make a comment, you can also, at the end of the presentations, raise your hand so that we can unmute you and then you can speak. As usual, our webinar is being recorded and will be made available on our website. Before I give the floor to our guests, please allow me to give a brief introduction to this project. OPERANDUM is the Horizon 2020 funded project that aims to reduce hydrometeorological risks by providing evidence for the usability of nature-based solution, best practices for their design, replication, and scalability. The project started in the summer of 2018 and will last for 4 years, includes more than 20 partners from 14 different countries. This large-scale project has several specific objects, all of them contributing to integrating of knowledge about nature-based solutions, strengthening technological innovation, improving acceptance of NBS, and strengthening the adoption of nature-based solution in policies. All of these methodologies are constructed around the concept of open-air labs, of which basically are large-scale demonstrator sites. And in total, we have 10 open-air laboratories in 14 countries, accounting for 26 different partners. But what exactly are nature-based solutions? Well, nature-based solutions is an umbrella term which includes several types of ecosystem-based approaches to deal with societal changes, such as disasters and climate risks. All of these aim at reducing physical exposure to natural hazards and increase socioeconomic resilience of people and communities. There are different types of nature-based solutions. Green solutions are inspired by terrestrial ecosystems. Blue solutions are related to fresh and marine waters. Mixed solutions combine green and blue solutions, and then hybrid solutions are integrated with engineering solutions. You will hear more about the different types of nature-based solutions from our speakers. The OPERANDUM open-air labs adopt a holistic view towards building resilience. The project focuses on a wide range of hazards, and this webinar series will address the different types and explore possible solutions. The open-air labs target 8 major hazards while considering the multi-spatial scale, different climate conditions, socio-cultural assets, and ecosystems and habitats. As you can see on the slide, there's landslide, hazards, coastal erosion, storms, droughts, salt intrusions, floods, heat waves, and nutrient and sediment load. Each of our open-air labs adopts a co-creation approach based on a stakeholder engagement at multiple levels. And this co-creation process includes the entire nature-based solution lifecycle, from co-designing, co-development to co-deployment and implementation, and also co-monitoring. The project outlines several stakeholder groups that are active at various levels, from local to international, which include citizens, companies, associations, policymakers, of course, the scientists, the media, and all sorts of stakeholders which might be interested in these solutions. In this sense, the co-creation process builds on various knowledge streams and addresses the specific needs of the different stakeholders. Now, to our guest speakers for today, we will have Alejandro González Olaru from Glasgow Caledonian University. Alejandro is a research fellow in applied ecology and soil bioengineering, and he's an expert in plant-soil interactions applied to solving civil engineering problems. He has also developed a number of numerical tools helping to answer complex environmental questions and has a solid record of high-impact scientific publications. He is the coordination of the Open Air Lab in the UK and leads the task which concerns the development and implementation of nature-based solutions across the Open Air Labs. We will also have Thomas Zieher from the Austrian Academy of Science. He's a postdoc researcher with a remote sensing background and a thematic focus on various types of landslides. He has interested in monitoring and modeling these features. He leads the Open Air Lab of Austria, aiming at co-designing nature-based solutions as an alternative to common practices for reducing the activity of deep-seated landslides. We'll also have Umesh from the University of Bologna in Italy. He's a postdoc researcher and his overarching research interests revolve around oceanographic and ocean wave modeling with specific interest in coastal wave modeling. In the OAL Italy, he works on the numerical modeling of waves with nature-based solution for the Emilia-Romagna coastal belt, which is part of the work package 5 of our project. We will also have Beatrice Pugnerenti, which is the associate professor at the applied physics in the Department of Industrial Engineering at the University of Bologna, and she is the coordinator of the Open Air Lab in Italy. And this is it for now. I will pass the word and give the floor to Alejandro now. So please, Alejandro, welcome.
Thank you very much, Sergio, and hi everybody. Good afternoon. This is Alejandro speaking. Greetings from Glasgow. I am a research fellow at GCU, and I'm the coordinator of OAL-UK, being responsible for all the research and engagement activities happening in the OAL, as well as for the design, deployment, and monitoring of nature-based solutions. I am also the leader of a task frame within the work package 3 of the OPERANDUM project, which focused on the development and implementation of nature-based solutions at the different OALs. During today's presentation, I will strive to provide you with some flavor of the story of OAL-UK and of what has happened here in the course of the OPERANDUM project. Please, next slide, Thomas. Thank you. I will introduce the geographic and socio-ecologic context of the OAL. I will outline its exposure to hydrometeorological hazards. I will outline who are the stakeholders and what co-creation strategy we devised and implemented at the OAL. And then I will showcase the interventions that we have deployed at the OAL to then finish briefly with the challenges and lessons learned. Next slide, please. So what about the location and features of the OAL-UK? Next slide, please. The OAL-UK is located in northeast Scotland, adjacent to Catherline Bay by the North Sea, not far from Aberdeen. The climate features of the OAL belong in the subpolar. Previous slide, please. Yes. The climatic features of the OAL belong to the subpolar oceanic type, comprising cold, dry winters and mild, humid summers. The average annual temperature is about 8.5 degrees Celsius, and the mean annual rainfall is of about 700 millimeters, being the prevailing winds southwesterlies like in most of the UK. Next slide, please. The OAL comprises a series of slopes and cliffs that roll into the North Sea. Atop the slopes, there is a small fishing hamlet, Catherline, with about 170 inhabitants. Most of the residents are newcomers who commute to and work in Aberdeen City, many working in jobs related to the oil industry. The hamlet has a relevant cultural heritage due to its scenic beauty, which has been portrayed by a famous Scottish painter, Joan Audrey, attracting many visitors every year. In fact, some of the cottages in Catherline are listed as historical buildings by the Scottish government. The area of the OAL is also rich in biodiversity. The cliffs and islands adjacent to the OAL are important nesting and breeding grounds for seabirds, seals, and other sea mammals like dolphins. The flora of the site is mainly comprised by pioneer herbs and grasses, but also by riparian woody species, which in many cases were planted by the local residents in the past to promote slope stability and landscape restoration. Next, please. So what is the exposure of the OAL to hydro-meteo hazards? Next, please. The slopes of the OAL are exposed to storm surges, but more importantly to the accumulation of surface water, generally coming from natural springs, which weaken the slope-forming materials, leading to severe episodes of shallow landslides and erosion following prolonged periods of rainfall. We have estimated that events with accumulated rainfall of 30 to 40 millimeters per day likely trigger landslides in the OAL. The nature of the slope-forming materials, mainly comprised by sandy silts originated in old beach deposits and glacier tills, worsen the issue, as these materials tend to be brittle when dry and plastic when wet. In addition, there is a sharp and shallow contact between the soil-forming materials and the bedrock, made of conglomerates, which also makes failure events likely and frequent. Next, please. In the time we've known the OAL and its residents, we've witnessed a series of landslide events, the first of which took place in October of 2012, and which have a dramatic impact on the Caterlines community as it blocked the access road to the beach and pier, which are the main recreational assets of the OAL. This landslide made the locals stop celebrating a very important event that used to keep the residents united, kart racing. The residents used to build their own kart prototypes and then race down the road to the beach, and landslides stopped these. Next, please. Yet the community is quite resilient, and a new recreational and economic activities have emerged, such as paddle boarding. Next, please. We also witnessed another landslide event right before the pandemic kicked off in February 2020, which blocked the road to the beach and pier yet again. However, the community were ready to act and they quickly cleared the road without waiting for the council to do so, so people could make use of the beach and pier during the first lockdown. Next, please. Not long ago, in last February, another landslide happened, this time in a zone battered by the action of the sea waves, but again, triggered by the accumulation of surface water. This landslide took place below a car park used by the community, raising the concerns of the most proactive residents, who have self-organized and formed an action group, and they are currently preparing a funding proposal to tackle coastal erosion in the OAL. Next, please. So who are the stakeholders in the OAL? Next, please. The primary stakeholders of the OAL are the people living in the OAL. Even though few of the residents have been born and bred in Caterline, there is a strong sense of belonging to the OAL. In addition, the zones of the OAL subject to landslides are contested land, meaning that technically speaking, no one owns the land. These factors, together with the landslides blocking the road and depriving the residents from the main recreational assets of the OAL, made the residents self-organize into an action group which has been working since 2013 to promote the stability of the slopes through the use of nature-based solutions. Next, please. This action group is known as Caterline Brace Action Group, CBAC. Brace means slopes in Scottish. And even though the group has seen better times, it's still quite active. And it has won some funding to implement nature-based solutions in the OAL in the past. We tend to organize regular informal meetings with them at the local pub, during which we can discuss in front of a beer or a whiskey about the project plans and outcomes, and about what the community can do to help. As the pandemic has not enabled us to celebrate these meetings, we have been sending the community regular newsletters in the forms of emails. However, I must admit that I wish we could have been more effective with the communication. There are other stakeholders as well that are important to the OAL, such as the local council, recreation groups, local farmers and businesses, with whom we also keep in touch and updated regularly. Next, please. What about the co-creation strategy that we devised for the OAL? Next, please. Well, our strategy comprised a comprehensive set of activities that were implemented sequentially and which are portrayed in this flow chart. In our case, it was the local community and other stakeholders, such as the local council, who approached us with the problem. So it was the local community who identified the hazard and its locations. Yet, we helped them to establish a baseline of the hazards by conducting site investigation. We also mapped out the stakeholders and we established an engagement strategy which involved different communication channels and activities depending on the type of stakeholders. The local community, but in particular its action group, has been closely collaborating with us to propose and develop nature-based solutions, evaluate their feasibility, select and design them. An intensive information campaign was implemented to establish a two-flow information exchange between us and the primary stakeholders and the end users of the OAL. Perception surveys and focus groups were organized too, for which we collaborated with our partners at the University of Glasgow. We then planned a co-deployment strategy for which we consulted primary and secondary stakeholders and for which we had the support from project partner Naturalea, who unfortunately could not take part in the deployment activities. Next, please. The deployment strategy involves the identification of landslide-prone zones first, for which we use both a computer tool and site visits for ground validation purposes. Next, please. And a concise plan establishing which nature-based solutions interventions go where in the OAL, having also in mind the creation of an open-air museum showcasing multiple examples of nature-based solutions. We also organize a practical workshop to teach local communities and other stakeholders about nature-based solutions and how they are deployed with the aim of building capacity in nature-based solutions, and by which we intended to deploy a number of interventions. This workshop was planned for late March 2020, precisely when the world closed due to the COVID-19 pandemic, which put on hold all our activities in the OAL and made us rescale our plan for the OAL. Next, please. We are still standing and we do not surrender easily, so we still managed to implement some nature-based solutions in our OAL, of which I will showcase some examples in the next slides. Please, next, please. In June 2019, together with the local community and using funding they won, we deployed ground anchors together with an erosion blanket on a zone subject to severe surface erosion. The ground anchors reinforce the soil and the erosion blanket protects the ground surface. We seeded the erosion blanket and we then place it a synthetic geogrid that degrades with the sunlight. Next, please. Vegetation is now taking over, and what it was a brown field exposed to erosion is now a green, stable field that attracts pollinators and small mammals, and where the process of plant succession has already started. Next, please. Most of the nature-based solutions that we have designed for our OAL involve the use of ground bioengineering techniques that use local earth and plant materials. These nature-based solutions are made of timber-based structures, promoting slope stability and protection. In last June, we managed to build 2 vegetative creep walls in our OAL with the help of a local farmer, his tools and machines, and of course, a couple of his workers. A creep wall comprises the deployment of timber logs forming a creep that is then backfilled with earth materials and then supplemented with plants and cuttings to promote the establishment of a dense plant cover, which hopefully will take over the stability role of the creep wall once the timber has decayed, decomposed, and become an intrinsic component of the ground. Next, please. The creep wall, this creep wall in particular was deployed at the base of a gully to stabilize the 2 walls of the gully while collecting the water running through it during wet periods. We supplemented the creep wall with local plant species that we have been nursing over the last year or so. Fingers crossed they will grow. Next, please. And yeah, I still have both fingers and toes crossed But what you can see in this picture are fresh willow shoots re-sprouting from the branches and cuttings inserted in the crib wall. This is essential for the adequate performance of the crib wall in the mid and long run. Please, next. We built a second crib wall in an area that fell in the 1970s, and we supplemented this crib wall with a live grating, which is a grid or lattice built with timber logs and which cells are then backfilled with earth and plant materials, again promoting slope protection and stability. The base of the structure was supplemented with a branch packing technique, for which we used branches and cuttings of basket willow that we found in the OAL. We were quite late in the season, and the summer has been so far quite dry, so the success of the later nature-based solutions is at risk, and we may need to implement corrective measures in the winter. Next, please. We also planted a large number of saplines atop the crib wall and lattice using local species we also nurtured on site over the last year. And we have fenced the interventions with wire mesh to keep the rabbits away. Rabbits have been an issue before, as they eat all the new growth, putting the success of the nature-based solutions at danger. Just to finish up this intervention and retain the crest of the slope above the live grating, we built a palisade also using timber logs. We still need to finish up this intervention to make it live, for which we will insert live cuttings of local plant species that they have the ability to re-sprout from branches and cuttings to promote plant establishment in the structure. Next, please. And good news, within 1 month after the construction of these interventions, we can already start seeing a vegetated ground cover developing and willow cuttings freshly re-sprouting. This is great, and hopefully our interventions will work as they are supposed to. Please, next. As I mentioned before, surface water accumulation is one of the main drivers of landslides and erosion in our OAL. And for this, drainage of the slopes is paramount. The construction of a live pole drain consisting in trenches filled with bundles of plant cuttings and local earth materials can promote drainage, debris retention, and when the vegetation takes over, soil water regulation through plant water uptake and landscape regeneration. We built a live pole drain in our OAL in April 2019, and which was evolving satisfactorily until the rabbits ate the new growth, making our intervention non-functional. Next, please. As you can see from the pictures, we are currently working hard to restore this intervention, bring it back to life, and keep the rabbits away. Next, please. Just to wrapping up, I would like to briefly mention some of the challenges and lessons learned in our OAL. Next, please. Possibly the list will keep growing, but so far we have experienced some fatigue in terms of the engagement with the local community with the project. I can think of several reasons why this happened, but this should actually be studied to some extent to gain some insights into the underpinning reasons. To my surprise, I have learned that the perception of the local community towards NPS was not so positive, with many residents preferring hybrid and even grey solutions. The reasons of this could have been the lack of effective communication, but also a wait-and-see behavior from the residents. We have not been able to deploy the interventions of nature-based solutions until very late in the project timeline due to multiple reasons and restrictions. So I can understand that many residents were waiting to see how the nature-based solutions we were proposing looked like, in spite of our efforts to share visual materials with them. I can tell now that following the deployment of the last interventions in June, the perception of some of the residents towards the nature-based solutions may have changed dramatically, as I never get such a positive feedback from them before. In any case, I believe that communication is key, and I wish we had done better at this. We have been a bit short in resources to tackle this effectively, and the pandemic has not helped. The season matters. It is crucial that plant-based interventions are deployed when the vegetation is dormant. we only had a small window to go ahead with our interventions in the OAL, and this did not match with the best season to work with plants. As a result, we may have to implement management strategies later on to make sure that the vegetation cover establishes on the interventions, which is crucial for the success and deliver functions and ecosystem services. Care must be taken with the cohabitants of the OAL. In our case, a pest of rabbits has affected dramatically to the ability of vegetation to establish in some of our interventions, which will have a negative impact on their performance in the short term. In terms of deployment, we have planned a co-deployment campaign, which looked very good on the paper, and which would have been great to promote nature-based solutions and capacity building. Organizing this was a lot of work and very time-consuming, as it wasn't just organizing the event, but also designing interventions, purchasing building materials, engaging with many stakeholders, suppliers, contractors. When this could not happen due to the restrictions brought by the pandemic, we tried to go ahead and build interventions ourselves, which we did. And I'm personally very proud of this. However, if we had subcontract the job, we would have had the interventions built in 2019. We could have focused on monitoring, and the time saved will have been translated into resources and money saved. Still, we had a very ambitious plan for the OAL and also a very persevering OAL coordinator, me. The ambitious plan was key because all the constraints we have encountered in the way has obliged us to downscale the plan several times. And even though we had to revise the scale of the plan on multiple occasions, we have still managed to implement a number of nature-based solutions. Without this ambition, I am not sure how many different nature-based solutions we will have managed to deploy. Next, please. I believe that we have now finished with the deployment phase in our OAL, and so we can now focus on monitoring the interventions to build an evidence base on their performance. We will also put some energy in the future to teach other people about our experience and disseminate what is going on at our OAL. Next, please. In fact, this and every year, pandemic permitting, we welcome a number of dedicated international students who take part in a series of research activities at the OAL, which has always been a great experience for everyone. We have also taught a local landscaping contractor how to build nature-based solutions, so he can now expand his business portfolio. And this is all from me. Thank you very much indeed for listening. Take care and bye for now.
Thank you very much, Alejandro. It was a very interesting presentation, and we really hope that everything goes for the best at your open air lab. I think this is time now for passing the floor on to Thomas. Thomas, please, the floor is yours.
Thank you very much, Sergio. So again, my name is Thomas Thier. I'm a postdoc researcher at the Institute of Interdisciplinary Mountain Research of the Austrian Academy of Sciences. And I'll present our results for OAL-Austria, which is the Vogelsberg landslide. So it's a bit of a different type of landslide compared to the ones in OAL-UK Alejandro was talking about. So in the background, you can see a photo taken from the opposite side of the valley, and it shows the whole slope, including the landslide. You can try to spot it, but I have to say that it's not as obvious as it seems. I will get back to that in a few slides. So I'll first start with an introduction to the Vogelsberg landslide before I show you the elements at risk in our OEL. I will present you then an overview of our involved stakeholders before I'm coming to the main steps of the MBS co-creation in our OEL, which are the problem identification and process understanding, the identification of NBS options, and the co-deployment and monitoring. Finally, I'll conclude and show you our next steps. So the Vogelsberg landslide is located east of Innsbruck, which is the province capital of Tyrol, a western province of Austria. You can see the location in the map on the lower left. In the picture to the right, you can see again the image taken from the opposite side of the slope. It's basically a vegetated slope with some forest patches and grasslands used for agricultural purposes. You can also see some buildings and respective infrastructure. And you can also see this delineation, this red delineation, and this is the approximate boundary of the actively moving deep-seated landslide. On the lower right of the image, you can also see this more obvious landslide type, which is a bit more shallow. This is the foot slope which collapsed back in 2008. So what we have here is a slowly, continuously moving deep-seated landslide covering an area of about 500 times 500 meters with approximately 5 million cubic meters of material moving. And the depth of the landslide is almost 50 meters. So there is obviously no way to stabilize the slope directly with some technical measures with anchors or also vegetation. So the roots of vegetation will not help to stabilize this slope. So as you could see on the image before, we have some buildings located on top of the landslides, and those show some slight tilting and also major cracks already. So you can see that on the pictures on the right, so the cracks are quite large already. In the meantime, one residential building had to be abandoned due to safety reasons. In the roads, you can also see major cracks, which have to be repaired again and again. And we also tend to see some degradation of the agricultural land and the forests. And due to this continuous type of landslide, due to the continuous movement, the residents are in a state of constant fear. They do not know how long they can live in their buildings. They do not know if it will be possible to reduce the activity, the movement of the landslide, and also the monetary value of their buildings currently tends to zero. And the infrastructure needs continuous maintenance, so to be fully working. So here is an overview of our involved stakeholders. I will not go into too much detail here. The figure in the center shows the main steps of the co-creation workflow applied in the OPERANDUM project. I want to highlight two of our local partners, the Austrian Service for Torrent and Avalanche Control, who is in charge of any technical measure against natural hazards. So they have been very important to us, and the cooperation in the project has been very fruitful so far. And the Federal Research Center for Forests. So these are the forest experts who evaluate the impact of forests and the hydrological potential for mitigating the movement of the landslide in future. So our main steps of the NBS co-creation, I'd like to highlight them just briefly. The first thing was problem identification and process understanding. So our team did not work in the study area before, so we had a lot to catch up. And a proper understanding of this type of landslide is definitely required for a proper NBS co-design. So the first questions we had to answer are the when, where, and why the landslide accelerated in the past. The second step was then, after we had a decent understanding of the landslide, the co-development of NBS options, so based on the available data, which we interpreted together with the stakeholders, and the results of several meetings and field trips, we were able to select NBS, which are actually feasible for a field experiment in our case. And after that, we were at the implementation and monitoring phase. We co-deployed a field experiment together with stakeholders, and the co-monitoring was implemented during the stage and is now ongoing. So I'd like to present some details about these 3 steps. So first, the problem identification and process understanding. So in the very first beginning of the OPERANDUM project, we of course did a stakeholder mapping. Some of the stakeholders we already knew from previous projects and the project proposal phase. Other stakeholders were then also invited by our local partners. So the group of stakeholders grew quite rapidly in the beginning. And of course, we gathered available data, literature, and discussed that during several meetings with single stakeholders, but also afterwards with all of them together and in focus groups to interpret the available data all together and to also define further steps for the process understanding. We did that also in joint field trips and co-monitoring campaigns. So the goals of this first phase, as I mentioned, was a comprehensive understanding of the landslide, to identify the causes and the triggering mechanisms of the acceleration phases of this landslide. And this, we definitely see this as a prerequisite for the NBS identification. We also narrowed down the affected area, so the area which shows these movements in the contrast to the surrounding area, which appears to be quite stable. And it was very beneficial that we had all the stakeholders and their different expert knowledge on board, because the interdisciplinary interpretation of the available data allowed us a deeper insight in the first place. And based on that, we made some common decisions about further required monitoring tasks to go even deeper. So I'd like to present you some of the results we achieved during this first phase. So regarding the question when and where, we have several monitoring techniques applied in this area. So the different stakeholders have their own techniques applied there. Our background is mainly the laser scanning, terrestrial laser scanning, but also UAV-borne laser scanning. And all together, we brought all the results together into one map on the right, where we can see basically points where we have information of the displacement over time, and the lines show the direction of the movement and also the magnitude. So this is a bit exaggerated, because otherwise you wouldn't see those few centimeters. But we now have a quite good understanding of the spatial pattern, the spatial displacement pattern. But of course, we also need the temporal dynamics, which are shown in the diagram on the left. And you can see that the velocity, the displacement rate of the landslide, it varies a lot over time. And it doesn't really show seasonal patterns, which we didn't understand first. So, for example, you can see that in 2017, the landslide suddenly accelerated in the second half of the year, while in 2018, it decelerated generally. So the damages to the buildings are mainly due to this varying velocity, and therefore we see velocity also as a proxy for risk in the end. So this brings me to the why. So we didn't really know why these irregular patterns of acceleration and deceleration took place, and that's why we applied an area-wide hydroclimatological model called Amundsen to prepare time series maps of incoming water, so different elements of the water balance. And these correlate quite well with the displacement time series. You can see that on the right, the upper one is again the velocity of the landslide. Below you can see the groundwater level, which is monitored by one of our local partners, and the aggregated rainfall maps over time. And lowermost graph is snowmelt. So after prolonged moist periods with above average rainfall, we see an acceleration of the landslide, but also after snowmelt. So that's why, based on this knowledge, we knew that any solution, including nature-based solutions in OAL-Austria, should aim at draining the slope above the landslide. And the measures are most effective in the upslope catchment area, not directly above the landslide, but further above in the forested area. So the objective, this brings me to the second step of the co-creation steps. So co-development of NBS options, and the general objective of NBS in OAL-Austria, as I said earlier, is to reduce the amount of incoming groundwater, so the infiltration in the area above the landslide. Together with our local partners and expert stakeholders, we identified 4 options which could qualify as nature-based solutions, at least as hybrid solutions at the Vogelsberg landslide. And we evaluated them in terms of expected effects and feasibility. So they are, first of all, to optimize the forest management in the uppermost part of the catchment area, to install drainage trenches along forest roads. So there are forest roads crossing the slope, like shown in the picture in orange. And along these forest roads, it would be quite easily to install drainage trenches. To seal streams and channels in the upper catchment area to prevent infiltration of surface water. So we observed that along several streams, water gets lost in the course downwards. And there are also some temporary measures installed right now, which I will show you later on, which our partners would have liked to replace by renewable resources. And one maybe rather exotic potential option to control snow accumulation. So we have considerable amounts of snow during the winter season, and during spring season, as we saw, the snow melt can also trigger an acceleration of the landslide. So one option could also be to install snow fences in the upper catchment area to collect snow and control the discharge of the meltwater. We see that for now as complementary measures in the overall mitigation strategy, which is elaborated by the Austrian Service for Torrent and Avalanche Control. And we had to discard 2 options, the controlled snow accumulation and the drainage trenches, because we didn't expect major effects by them. So what we kept in mind was then the optimization of forest management. And as you might think, this is a rather long-term measure, and it requires a large area to be reforested. So this is a very long-term measure. So we need evidence before we can go to the landowners. This is all privately owned, and to try to convince them to manage their forests in a different way. There is quite some potential. You can see that on the map. The red areas are currently clear cuts, and the yellow areas are areas where we have young forests, which could be managed in a better way. And And in general, we look at the potential of introducing mixed forests, facilitating multiple vegetation layers instead of only one canopy layer, and establishing a ground cover of 70 to 90% instead of a full coverage to facilitate several vegetation layers and to adapt grazing practices, for example, to reduce the number of livestock over there. So what we're doing with that is to compare current and potentially optimized conditions in a modeling case study. You can see that on the right for now. So the left plot shows the water balance, the mean water balance for current conditions on clear cuts. To the right, pole timbers, so the intermediate forest ages, and in the red, on the right, the mature forests, so the water balance for mature forests, and you can see that we get less infiltrating water on the properly managed forests, simply due to evapotranspiration. So what we'd like to do, we'd like to show that a properly managed forest can enhance evapotranspiration, and we get less infiltrating water into the underground, which will reduce the hydrologic forcing of the landslide. So as I mentioned, this is a long-term NBS since the development of proper forests takes time. For the residents, such a solution will likely come too late. So we were looking also for short-term solutions. And that's why we came up with an idea we discussed during several meetings with our local partners to what they did as a first reaction, as a first response to the landslide events in the past. They installed temporary measures to prevent infiltration losses along leaky stream beds. You can see that in the right picture. They installed some polyethylene half shells to discharge the water. This is a temporary measure because it could be severely damaged during thunderstorms, for example. So they told us they would like to replace that with a more long-lasting measure. And what is a common practice for that is to dig a trench and to introduce some synthetic layers like a pond foil or polyethylene pipes, which we do not consider as sustainable ecological management. And we were looking for an alternative for that. And we found a bentonite mat, which could be an alternative solution. This is a composite of needle-punched geotextile layers and the bentonite filling. Bentonite is basically a mixture of clay materials with a high swelling potential under saturated conditions and a sufficient overburden. And conventionally, up to last year, such bentonite mats are including synthetic geotextiles, which may not qualify in environmentally sensitive cases and which wouldn't be a real renewable alternative to the conventional solutions. So we got a prototype to test this alternative, which is a biodegradable bentonite mat where the geotextile layers will decay over time, but the bentonite layer remains in place, ensuring the sealing over long time spans. So we're talking about hundreds of years. So in the co-development phase, we designed a prototype along a 25-meter long stream section, which was rated as which had a leaky stream bed before, and we came up with a design proposal, which we refined during several online meetings together with the manufacturer and local partners. After that, we could start with the permitting pathway, where we had to submit a detailed description of the intended implementation and potential environmental impacts. but also the documentation of the original conditions, because in this case, the post-implementation conditions should be rather similar regarding the topography, but also vegetation. And this is also inspected after a defined period, which is 3 years in our case. This brings me to the implementation and monitoring phase. So we did some preparatory tasks and measurements to assess the baseline conditions before the co-deployment regarding topography, vegetation, and subsurface characteristics. And we prepared the bentonite mat and the ditch beforehand. During the co-deployment in the field, we shared required tools, materials, logistics, and the costs between all involved partners. We got additional support from the residents who provided material, but also their machinery. And we got assistance and instructions from the manufacturer who traveled quite a long distance to be with us during the co-deployment. And we also installed the continuous soil moisture monitoring below and above the bentonite mat. So the goal of our monitoring campaign is now to assess the performance of the bentonite mat along this stream section. We use several techniques to do that. For the subsurface characteristics, we use electrical resistivity tomography, which we measure along the red profile, along the red transect, I have to say, in the upper right map. We installed several soil moisture probes at 2 soil moisture monitoring profiles below and above the mat, and we assess topographic changes using the terrestrial laser scanning. So we established time series of environmental variables, and our baseline are the conditions assessed before the implementation. And our target is that the soil moisture shall increase above and decrease below the bentonite mat. In this way, we show that it's effective and has the same effects as the technologies used right now. So I'd like to conclude my presentation. So first of all, in our case, process knowledge is definitely key. We had to start from scratch, but these necessary first steps also brought us closer together with our stakeholders. Also the benefits of this interdisciplinary perspective, so the close cooperation with the stakeholders, also analyzing data, was very beneficial. And we see this process knowledge in our case as a prerequisite for a proper NBS co-creation. We saw that, and this brings me back to one conclusion also Alejandro drew, our stakeholders, they told us, yep, please show us first what are the effects of the NBS. Can they really perform as well or even better than our solutions we usually use? Also, the residents were a bit, wondering if these are the proper solutions, and also the co-benefits should be emphasized. For example, in our case, it's the ecologically sustainable management, which also the environmental agencies were quite fond of, and this could bring advantages for the permitting path. So the overall mitigation strategy could be permitted more efficiently. We wonder about the economic and social dimension of sustainability. So economic, we could see that so far that we do not require much maintenance compared to the traditional measures, but we definitely have to investigate that in more depth. And also, as I said, the feasibility. We have to prove that first, that we can keep up with the existing approaches. Okay, with this, I would like to close close my presentation. I'm looking forward to any questions in the Q&A after the next talk. And with this, I'd like to hand back to you, Sergio.
Thank you, Thomas. Thank you very much. Again, another very interesting presentation. And I'll pass the word on to, I think it's Beatrice, who will start from the OAL in Italy. So Beatrice, the floor is yours.
Thank you. Can you see my presentation?
Not yet. We can now. That's it. Perfect.
Okay, good afternoon. I am Beatrice Pulvirenti and I am the OAL Italy leader. And this afternoon I will present one of the NBSs which in the OAL Italy we are going to implementing. That is a dune. The construction of a dune in a beach on the Adriatic coast. In this picture, you can see the North Italy. In particular, this part is the Adriatic coast, and this one is the North Adriatic Sea. And this coast is for us very important because there are historical sites in the inland, but there are also industrial activities, farms, fish farms, and so high human involving activities, and it is one of the main touristic system of Europe. So in case of storm surges, marine erosion and water floods, especially water floods could damage forests or the freshwater ecosystem and also the biodiversity. So this coast is for us fragile and to be protected. In this coast we have two sites. The first one is Bellocchio Beach, located here. The second one is Volano Beach, 20 kilometers north with respect to Bellocchio Beach. They are in the Po Delta Biosphere Reserve by UNESCO and in the Comacchio municipality by Ferrara, that is in Emilia-Romagna. The Bellocchio Beach, in particular, this one here, is close to the mouth of the Reno River, Italian Reno River, and borders a lagoon, shown in this picture here, from the sea. While the Volano Beach here is close to the Po Delta, and it is located between the sea, as you can see by this picture, and a vast pine forest. At the beginning, the Bellocchio site was selected as a first site for the project, but unfortunately a strong storm surge event eroded the beach. It was last December here in 2020. Here you can see the picture of the flooding event, and we had an erosion, strong erosion of all the beach, longer than 30 meters. That's why we moved to Volano Beach, and this picture can show how it is urgent to show to the people the co-benefit, like Thomas was saying, of this kind of actions that we are going to implementing and studying. The partners involved in this project are the University of Bologna for the leadership and for the coordination, the ARP Emilia-Romagna for the coordination, the design support, numerical modeling, and also the monitoring, Rina Consulting for the design of the dune, Naturale and Iris for the design support, and local stakeholders like Land Security and Civil Protection Regional Agency for the construction of the dune, and Carabinieri, that means police department for biodiversity in that area for design support, but also for the permitting support and construction. These are the design environmental reports that we built in the last 2 years, but first I wanted to introduce the project, why we selected a dune like NBS. because an artificial dune that is made with the natural materials represents a barrier between the sea and the land, in the same way to a seawall that is an hard structure. In contrast, dunes are dynamic structures, and the interaction between the dune and the beach gives constantly small adjustments in response to changes in wind and wave or sea level. And our structure in these beaches would be too impactful. So in this context, we want to show the benefit, the co-benefit that people could have with this kind of NBSs. So the project for the Bellocchio site, the first one is shown here. This is the plant, the sketch of the dune, see from above, with the two cross section, because this dune is made by two parts, one with biosoil reinforced with coir net, connected with another one made by tubular modules, again in coir net, plus hinge systems subjected to a patent by our partner Rina Consulting. This artificial dune will be constructed using natural materials such as sand, wood, geotextiles, and geomembranes made of coir fibers. The same approach has been chosen for the Volano beach, so only the layout is different. As you can see, it is a straight dune, smaller with respect to the first one, but with the same cross section. So the same two parts, one with only biosoil and the one with the tubular modules. And here you can see a three-dimensional idea of the dune near a human, near a man. So the dune is protected at the ends by horizontal bundles of wood in trench and vertical bundles of heather in trench that has the function of trap the sand, protect the front of the dune, and avoid undermining of the work. Finally, the surface of the dune will be covered by sand and vegetation. That means sand covered by additional coir net with an erosion and runoff control system and vegetation. Particularly, the front of the dune will be covered by a selection of these plants, and the top of the dune will be covered by one of these ensemble of plants, while the back by means one or more of these. The construction of the dune is strictly connected by monitoring campaigns in order to evaluate the efficacy of the dune and to access also the morphological evolution of the artificial dune and of the beach, in order to assess the ability of the dune to counteract the coastal erosion phenomena and to reduce flooding events in the inland area. We made and we are planning other topographic surveys and bathymetric surveys. The topographic surveys will be made by GNS satellite geodetic receivers in RTK mode, plus unmanned aerial vehicles, and the bathymetric surveys by single and multi-beam systems. And here in this picture you can see the grid of the points of the measurements that will be planned before and after the implementation of the dune. Also, structural monitoring is planned with sensors embedded in the cover of the dune. In particular, we will add distributed optical fiber sensors to the structure, so we will integrate into the structure that will provide data regarding the longitudinal and circumferential strain. So along lines on the top of the dune, you can see these red lines. These sensors will measure the longitudinal strain, while around the tubular modules here, the sensor will measure the circumferential strain. This data will be measured statically, with the sampling interval around tenths of minutes, and they will provide very precious information about the structure, the modification in the structure. We have a huge unit for simulation in the OAL, like in the OAL-Operandum project, that made one-dimensional and two-dimensional simulations for NBS design and sizing, parallel to the co-design process, and for the simulation for current and future scenarios with and without NBS, for the demonstration of the ability of the NBS to counteract the flooding, coastal flooding events. These results will be presented in a dedicated webinar because they are very huge, together with the other modeling approaches present in Operandum. Finally, last but not least, the co-design, co-development and co-deployment process we adopted for this, we are adopting for this implementation of this NBS is very complex. It can be seen here as a two-path, very strictly dependent. That means a co-design path where from the preliminary design we go to the design for construction made in spring this year. That is strictly connected with the involvement of the local authorities like the Regione Emilia-Romagna and the conference, by means of the conference of services, by the involvement of the local authorities. So this permitting path was very long and complex, and it will be finished this summer with the remediation, with the final permitting approval. But parallel, we involved the local stakeholders together with the Civil Protection Agency, that will be the constructor of the dune, in all the processes, in all the paths of seen above. Because of pandemic, the initial meetings in presence will continued with the online meetings, sometimes in presence if possible. And in order to increase the involvement of the local stakeholders, we started a forum. And at this forum, we had both the stakeholders directly involved in the process and also other stakeholders that are involved in the coast Adriatic of the Adriatic Sea. As this storm surge event destroyed the Bellocchio beach, as I said, in this point temporarily from left to right, we had to reinsert a co-design, so modify the co-design approach, and now we are we obtained the design for construction, modify the permits path, but we are now ready to start the deployment, the building of the dune next winter. Finger cross. With this, I finished the first description of the first NBS. This is the real one, let us call it real one, for the OAL Italy. And now I leave the word to Umesh, because we have another NBS that is virtual to see, because we want to show to the stakeholders that by means of other NBS we can mitigate the storm surges and marine flooding. So Umesh, I leave you the word. Umesh, yes.
Yeah. Thank you, Beatrice. Can you see my screen?
We can, yes, thank you.
Yeah.
Yes.
Thank you, Beatrice, for giving us this introduction about the coastal dune. Hi, everybody, and I'm Umesh from the University of Bologna, and I'm working under the OPERANDUM project. And today I'm going to discuss with you some of the results that we have obtained under the NBS, which is nothing but a multi-modeling system, along with the seagrass application that we have executed along the Emilia-Romagna coastal belt. So to start with, let's have a look at the main hazards, that's the hydrometeorological hazards that we experience along this coast. So we know that most nearshore regions experiences weather variability such as storms, droughts, and floods. And these climate change is projected to increase to the coastal environment through drivers such as sea level rise, changes in wave direction, increases in swell energy, and storm tide events. So what we have to understand here is that these are the drivers that affect the coastal erosion, sediment supply, and inundation. And these are expected to vary geographically across the coastal zone. So in the Emilia-Romagna region, we understand that this region is subjected to erosion and inundation. And you can see from this slide, the observations, the pictures that we have from this region, where on the right side, you can see the erosion of Bellocchio Beach at the Lido di Spina, which occurred in 2016, and some observational evidence of the escarpments at the Bellocchio Beach. So this is a region where we are trying to model out and bring out some nature-based solution, because this region is subjected to inundation and erosion due to storm surges and waves. So the main objective of our work is to numerically simulate the effectiveness of NBS in the Emilia-Romagna region against the surge and erosion. And so the adapted NBS here is nothing but a seagrass meadow to decrease the wave and surge amplitude. And also, as Professor Beatrice has explained, we also have the coastal dune to protect from the coastal inundation. So having a look at the region, the Emilia-Romagna region is located in the northern Italy, in the northern Italy facing the Adriatic Sea. And the coastline stretches over 130 kilometers and is composed of low-lying sandy beaches, which are mainly dissipated. And it is heavily urbanized, and especially in the central southern parts. And since 1970s, large hard protection structures or large number of structures have been constructed to protect the coast from erosion and inundation. And the coastline is exposed to storms from the east, northeast, and southeast directions. And the prevailing winds are from the same directions, that is Bora and Sirocco. And they are able to generate the significant storm waves and high surge levels, although the model wave wedging is of very low energy, that is about 60% of HS being below 1 meter. So this is just to give an idea about how the region behaves. Like, I've taken this from a literature of long-term shoreline changes from 1984 to 2016. So the first figure you can see, this is the Emilia-Romagna coastal belt. You can see the red one denotes the erosive shorelines, and the green bar denotes where the shoreline accretion has happened. So this is the region where you can see the red patch, that's the red lines, which denotes as the shoreline indicative of the erosive shorelines. And if you look at the zoomed image of the Bellocchio, which is from this region that I've zoomed in, you can see that here, this is an area that has to be really taken into consideration for such an application. So the first choice of the location that we chose was the Bellocchio, and later on we have shifted the site because of the storm that has happened recently there. So in this study, I will be discussing you the results with this location of Bellocchio. So if you consider the world sandy beaches, we see that the 24% of the world beaches are eroding at a rate of 0.5 meter per year, and 28% are accreting and 48% are stable. So this is something a serious concern, to have some solution for mitigating out these effects at the coast. So in this OAL-Italy, apart from the coastal dune, the NBS that we have is nothing but the numerical sedation with the marine seagrass. And mainly what we have implemented is, we have modified the bottom dissipation stress due to the vegetation. And mainly we know that these coastal habitats, the main important aspect is that the stem density and flexibility, these are the main factors that drives in reducing in bringing out the dissipation capacity. So large, they are dissipators, they are helpful in dissipating the energy, mainly because these submerged canopies can reduce flow and turbulences, and they can increase the bottom shear stresses and dampen wave energy and flow velocity, thereby promoting the sedimentation as well as reducing the sedimentary suspension. So keeping these facts into consideration, we have executed the modeling in this particular Emilia-Romagna region. So we have used a combination of models such as a hydrodynamic model such as SHIFM, the wind wave model, WaveWatch 3, and a sediment transport and morphological model which involves the X-beach. So the outputs from WaveWatch 3 and SHIFM will go to X-beach, that is mainly wave height, period, and direction from WaveWatch 3, and the sea level from SHIFM, and then X-beach is used to evaluate the erosion in this area. So we carried out long-term simulations for the present and future climate in this area. So now let's look at why this marine seagrasses is important and how it can attenuate. So mainly, you can see in the figure that it brings out the wave energy dissipation at the coast, mainly by the roots of these seagrass plants have the capability in the trapping of these particles, which can also have many other additional effects of carbon deposition and carbon burial and many other effects, which is not mainly the concern of our study, but our main interest would be that it acts as a buffer against the sea level and also in dissipating the energy and mainly to act as a physical barrier. So these plants also have the capability to grow and repair and adapt themselves. So this can be considered as a very important tool for combating the climate change. Now, if we have a look at the seagrasses sites in Europe and their trajectories based on data from 1869 to 2016, we can see that there is a decline for the species Sostera marina and Chimodicia, but the lowest is Posidonia. But if you check the area around Italy, the region around, you can see that we have declines of Sostera marina and Chimodicia, which were present there. So in our implementation, these are the four types of species, that is marine, Sostera marina, Sostera nonti, Posidonia, and Chimodicia. These are the four species that we have that occurs along the European coast. But we have chosen Sostera marina because it is evidently seen in the central Adriatic and the northern Adriatic, and it occurs in regions where the mean wave heights is less than 0.4 to 0.5 meters and where the irradiance is greater than 33% of the surface irradiance. So what we have to take into consideration while using these type of vegetation is mainly the characteristics of these plants, such as the diameter, the number of plants and length, which varies for these species. So on this right side, you can see the seagrass belt position in the Bellocchio region, where it has been inserted in the 2 meter to 10 meter depth region in the Emilia-Romagna coastal belt that is mainly in the Bellocchio region. So this is the main thing that we have carried out in our implementation. You can see on the left side, which is nothing but an aerial photograph along the coast of northern Adriatic. So you can see that from 1973 to 1983, there is about a 72% loss of seagrasses. Again, from 1989 to 2004, a recovery of 63% of seagrass extension has happened. Again, from 2007 to 2013, there is a decrease in seagrass extension, and it is almost the same as 50% of the area covered in 1973. So from these images, that is from aerial photographs and field surveys, we could see that the seagrass landscaping is chosen to reproduce the natural distribution of seagrasses, as is evident from the satellite images. So on the right side, you can see along the 2 meter to 10 meter depth contours, we have implemented these type of designs, that is mainly a native one, which is LS1, then low density cluster LS2, and a continuous strip LS3, and broken strips in clusters of LS4. And you can see that the LS4 one, which gave us good results in reducing the wave amplitude at the coast. So giving out in the coming slides, I'll show some results that we have from the modeling studies. So these are the results from the wave model. So you can see in the comparison of wave height with and without vegetation, we could achieve significant reduction. mainly with the LS4 combination. So, and when we come to the spectra, we can see that the red one denotes as the one without vegetation, and the other are using the different types of landscape arrangements. And you can see that sufficient reduction of energy has happened, and the short period waves are almost completely dissipated. So this is in fact a good achievement that we could achieve, that we could get along the coast. And when it comes to the context of seasonality, we could see that there exists a strong seasonality in the context of waves, that's mainly in wave energy reduction. You can see here the differences in August and November, where in August we see comparatively lower and comparatively higher attenuations in the month of November. And considering the hydrodynamics, what we could see is that there is no significant effects on sea level, but we could get decrease of velocity due to vegetation, that is about a 5 centimeter per second. Bottom current was reduced to about 1 to 2 centimeter per second. So with the application of vegetation, there was decrease of velocity due to vegetation, but the seasonality was very small. So to conclude, the NBS impact that we could achieve along the coast and the lessons that we could learn is that the Sostera marina was helpful in reduction of wave height, and mainly the seagrass landscaping is an important aspect in the reduction of wave energy. And in our context, in our case, the broken vegetation strikes in clusters gave the most effective reduction of wave energy. And in case of waves, there exists a strong seasonality in the wave energy reduction, with higher attenuations in winter and comparatively lower in summer, which is mainly due to the differences in the wave spectra. And in terms of sea level, the reduction due to seagrass is negligible, but important changes is noted in the bottom currents. So the next steps that we would like to look at is nothing but the limitation that we had was these experiments were carried out with rigid seagrasses. So an advanced parametrization using flexible seagrass will be looked into. And not only that, the several approximations that we carried out, like the fact that the seagrass is rigid and this will overestimate the real world impact of the NBS. So our results can set a little an upper limit for the decrease of wave amplitude in the coastal area, and the sea level, the overall effect is very small. So what I would like to conclude here is that the NBS that we have designed is instantly perfect, but at the same time it can also be fully dynamic, and it will improve and degrade over time according to the events the coast experiences. And so we will have to have more work be needed to find out the optimal setting of the degradation and the positive impacts on the wave runoff, especially the part contributed by the storm surge hazard. So I conclude here, and thank you very much. These are our working group along with RP and CMCC. Thank you.
Okay, thank you very much, Umesh, and thank you very much to Beatrice, Thomas, and Alejandro for this incredible insight into what's happening in the OALs across Europe. I'm not sure if anyone has questions. I can't see any questions put on the chat. If anyone wants to make a verbal question, you can also raise your hand if you want, and I'll unmute you. Well, if not, I do have a question, and this is a more generalistic question that, well, if any of you wants to take upon. I've been paying attention to some of the things you've been saying, and it's interesting to see that both Alejandro and Thomas mentioned that stakeholder engagement was somehow an issue, or at least building confidence. I think Beatrice also mentioned that building confidence with well, some of the stakeholders, namely the inhabitants and the people who are somehow affected by these problems. How would you see, and coming myself, I'm a geologist, has a background, but what I do is geoscience communication and communicating towards the greater audience. What would you say that could be an important tool? How do you see that is the one of the important tools that you could use to address this issue of public trust, or to make people adhere to these solutions that you are proposing? Do you have any ideas, any suggestions, any thoughts on it? Anyone who wants to take up on the question.
Yeah, well, if nobody, I just go ahead.
Yeah, go ahead.
I mean, I don't have an answer to that really, but I think the more you communicate with the stakeholders, the better. And obviously you need to tailor your or the communication avenues depending on who are you talking to. It is not the same to engage and speak with local residents. For them, for example, the most important thing will be face-to-face communication as much as possible, but also they always want more information, so they like reading emails, so they have an opportunity to then go online and corroborate and find new information, but then they want to discuss that face-to-face with you. If you need to engage with a local politician, maybe the best thing will be phone him up, give him a phone call. If you need to discuss with a company and keep them informed, maybe the best is emails because they won't be bothered to answer your calls. However, they will read the emails on a regular basis. There is no one answer, okay? Yeah. However, I think it is important to have a very intensive communication campaign ready, to engage effectively with many stakeholders and be transparent. Be ready to be transparent.
So, we have a question here. Yeah. So, the question is, did you find the EIA procedure involved helpful for project designing success, or was it more of a regulatory hurdle to get through? I'm not sure if is a directed question, but I assume that it's directed at anyone. I would say it's the environmental impact assessment. Well, yeah, anyone. So if you want to, I don't know, Alejandro, Thomas, Beatrice, Umesh.
We didn't carry out an environmental impact assessment in our site. We did a site investigation, and but we didn't have to go through most of the permitting paths that, for example, Beatrice or Thomas were talking about, because we are working on a place that nobody owns the land, really.
In our it was helpful for the success of the permitting path, and also it gave us the possibility to enhance the communication, as Alejandro was saying. So by means of this, we had many more meetings with the stakeholders for convince them of the success of our project.
Yeah, maybe what I can add, in our case, it was a very smooth process, the permitting path, because there isn't too much interference with the ecosystem. Also because we have a renewable alternative to otherwise synthetic materials, so they were quite fond of this this alternative. I'm talking about the environmental agencies who performed the assessment. So it was very welcome, and it also started a more close cooperation. I wouldn't call it cooperation, but discussion with the environmental agency, and they had some very helpful inputs as well.
Okay, thank you for your answers. They've been very interesting insights here. Yes, I was also wondering whether, because coming back to the issue of communication, do you find that there is somehow a difficulty in local populations or local stakeholders to understand the level of risk and understand the solutions that you present, or isn't that the issue for you for your regions?
For our case, they are aware of the risks, and the picture that I've shown show it. Then I think that the problem of coastal erosion is a problem that the citizens and the local stakeholders know very, very well.
Okay, that's good.
I agree with Beatrice. They are very aware, and they do understand very well the hazards and the risks involved. However, I found in our OAL that there wasn't a clear understanding about what we were proposing. In spite, we were explaining in layman terms to the community, and we were kind of using a lot of visuals with them. They were not kind of buying in. I mean, not everybody, okay, but there were some people who were saying, why we're gonna do this if it is not gonna work? Why won't we just go and put some concrete there because concrete is king and blah blah blah, you know? So that's the kind of people you need to take care of, and be very responsive, and treat them very well, and make sure that they end up understanding, because that's the people that we need to bring on board.
Yeah, I agree. Actually, we have another question, and then we close the session. So while reducing infiltration through forest management, did you consider the impact on groundwater balance? I would say that probably for Thomas here.
Yeah. Of course, we are aware that we will change the water balance, also the amount of groundwater there. That's the goal, of course. And that's also a big issue, because many people living there rely on private wells, which could potentially fall dry. So first of all, we need to establish an alternative drinking water supply, which is currently ongoing and very slowly proceeding. But of course, we know that we could have other impacts which we cannot foresee perfectly. But the first goal is, of course, to reduce the velocity of the landslide. So everything afterwards will be, we need to find a balance.
Absolutely. So, and for the last question, well, actually, there are questions now coming through, so it's not the last question. I would say, so how do you prove that nature-based solutions can perform equally or outperform other solutions such as grey infrastructure options if nature-based solutions have not been tested on the project site before? Do you think that hybrid solutions would be more attractive to many different stakeholders? I think this is a question for the general, for anyone who wants to take on.
I think that our NBSs, together with monitoring and measurement, together with modeling, can show at least as an extrapolated result the differences between a full green NBS and an hybrid one, and also the economic impact and the co-benefit. So I think that the role of Operandum with the OALs is exactly this one, to show to the stakeholders the differences as better as we can.
To demonstrate, right? To prove them that it works somehow.
So of course, if we had more time, like if the project had a duration of 10 years, we could definitely provide better evidence, but we will try our best.
Yeah, I think that's a very, very interesting point that you're raising there, Thomas, because, and coming from the communication side, that also connects to communication, right? Because it's very difficult for people to perceive that the time that it takes for science to reach conclusions, it's sometimes not it doesn't match the time that people want those solutions to be implemented, right? People want solutions for now, but we need time to investigate whether they are applicable or not, and it's tricky to find that balance. So I think there's a few other comments here. I say, in terms of the stakeholder response to nature-based solutions for such more areas like Hatterline, for example, but also other areas, maybe nature-based solutions will be the only option because governments are unlikely to pay to build seawalls everywhere. And I think the UK has a managed retreat policy in some areas. Yes, very interesting point here. Also, Jenny is saying, asking for the projects related to landslide migration, is there no tectonic activity that causes the landslide? And do the government has a share to the financial cost of the project implementation? It's actually a very interesting question that I was going to raise as well in terms of the tectonic activity.
Well, in our study area, basically in the province of Tyrol, we have the potential of, I think, magnitude 6 earthquakes, for example. But our partners at the University of Bologna, who have specialized on the effects of earthquakes on slope stability, had some model runs, and they concluded that these typical, let's say, magnitude 2.5 earthquakes will not have any impact on the landslide, and if it was a severe one, then all our slopes are might fail. So one more doesn't really count then. But regarding the second question, yes, of course, the government will spend considerable amounts of money for the final project implementation. So for the overall mitigation plan to drain the slope in our case.
Okay. Well, I think we could close the sessions quite long now already. So thank you very much all. There's one last comment. I think it would be very interesting to connect with OAL-UK to explore how to communicate local research and monitoring with communities and local stakeholders, as they have to be part of the process of where these go beyond demonstration. Yeah, absolutely, I agree. Well, anyway, thank you very much. Thank you very much. And the presentation and the webinar will be available on our OPERANDUM's website. So anyone who wants to review or see, who hasn't seen it, it will be there. Also, the contacts of our researchers are available. So if anyone wants to contact you guys and take on and connect, I think you're very welcome. Again, thank you very much to all for joining us, and for our presenters, especially for these very interesting insights on your work. And see you next time. Thank you very much. Bye, guys.
Bye-bye.
Please, bye for now.
Thank you. Bye-bye.
Bye.